Okay, part A of this question asks us to simplify certain fractions with surds in them. To add or subtract two fractions, we need a common denominator. I'm going to take it by multiplying these two denominators together, and you hopefully notice that if when we multiply these together, we get the difference of two squares. So our common denominator is going to be 3 plus root 7 upon 3 minus root 7. And on top then, this first fraction, I need to multiply top and bottom by 3 minus root 7. So it's 6 upon 3 minus root 7. On the right hand fraction, I've got minus 4. Don't forget that negative sign. So it's minus 4 upon, well, to get our common denominator, we need to multiply this fraction, top and bottom, by 3 plus root 7. So, on top then, we've got 6 upon 3 minus root 7 is 18 minus 6 root 7. And minus 4 times that is minus 12 minus 4 root 7. On the bottom line, we can expand these brackets as normal if we wanted, or if you notice much more quickly that this is the difference of two squares, we're going to get 3 squared subtract root 7 squared. So 3 squared is 9. Subtract root 7 squared is root 7 times root 7, which is just 7. So overall we have 18 minus 12 is 6. Minus 6 root 7 minus 4 root 7 is minus 10 root 7s. And all over 2. And again, we can simplify that. We can divide everything by 2, because it does say in the question, simplify as far as possible. So that's 3 minus 5 root 7. So we've simplified that as far as possible. The next question asks us to simplify algebraic fractions. Now to do this, we're going to have to factorize as much as possible. And if you notice this first one, 4x squared minus 9, we should be looking out for difference of two squares in this. This is 2x squared, all squared. This is 3 squared. So that's 2x plus 3 upon 2x minus 3 over x plus 1. And we're multiplying that by something over 2x plus 3. Again, this is a very straightforward quadratic expression where two numbers multiply to give minus 5 and add to give minus 4. So that's x minus 5 and x plus 1. So we've now factorized all the different parts of our expression. And we know that when we multiply fractions, we multiply the tops and we multiply the bottoms. But before that, what's easier to do is to cancel anything in the top, any factor in the top that is a factor in the bottom. You'll notice here we have a factor of 2x plus 3 in the top and a factor of 2x plus 3 in the bottom. We also have a factor of x plus 1 in the top and a factor of x plus 1 in the bottom. And so we're left with just simply 2x minus 3 upon x plus 5. And we're just going to leave it like that. And we don't need to multiply that out. That's as simplified as far as possible. Final one. Solve this equation. Now you notice everything is in powers and indices. We have everything in terms of 3, because 27 is a power of 3. In fact, it's 3 cubed. And that's all to the power of x. On the bottom we have 3 to the power of x minus 1. And over here we have 3 root 3. Now we need to be a little careful here. That's 3 times. I'm just going to put a dot for the times there. Root 3 is 3 to the power of a half. The square root of 3 is that. Okay. But this is 3 to the power of 1 times 3 to the power of a half. So we could rewrite this as 3 to the power of 1.5, or 3 over 2. Okay, remember, when we multiply numbers with the same base, we add their indices. So 1 plus a half is 1.5, or 3 over 2. Our rules of indices also say that if I have a power and I raise it to a new power, I multiply them. So this is 3 to the power of 3x. And again, 3 to the power of x minus 1. So keeping going, we want to move this part of the fraction, move it across to the other side. So we have 3 to the power of 3x is equal to 3 to the power of 3 over 2 multiplied by 3 to the power of x minus 1. So 3 to the power of 3x. Again, on the right hand side here, we are multiplying these two numbers, so we add their indices. So that's 3 to the power of x minus 1 plus 1.5 is x plus a half. And now we have that 3 to the power of something is equal to 3 to the power of something. And so we can say that the indices must be exactly the same. 3x must equal x plus a half, or 2x equals a half, so x equals 1/4. And so we've solved for x.